Hey everybody, this is Dark Garzum, and we're back here with a quick chat to cover a few small questions. So I constantly get kind of asked, well I wouldn't even say constantly, it occasionally happens. I get asked kind of how I know how to program, how I started, how I learned everything, and etc, etc. And it'll be kind of surprising to find out that it's not as complicated as it may appear. I didn't just magically one day wake up and learn how to program, and I wasn't just taught by a master wizard. I learned the same way everybody else learns. I started small and I worked my way up. To kind of give a story emphasis on this, I'll go over my entire lifetime experience with programming and point out kind of what parts matter and what parts don't. Good way to indicate this: anything that happened before 2011 doesn't matter, but we're going to go over it to begin with anyways. So my first exposure to programming happened when I was a little kid. And I actually tell this story a couple times and people laugh and joke thinking I'm kind of making it up because it doesn't make any sense. I learned how to program with electronics. So when I was like 3 or 4, my dad bought me an electronics kit from Radio Shack. He wanted to teach me how to do electronics. I actually found out later in life the reason he wanted me to do this is because he wanted to push me to become an engineer, because he couldn't be an engineer, but that's a story for another time. But he brought me a little electronics kit, and one of the very first things that came with it was a dip switch. It's a little, let me actually get a picture of this. I probably should have prepped some material firsthand. But it's a little piece of electronic board piece that looks like this. It's got a few switches on it, and you can do stuff with it. So I learned, my first experience of programming was with this. I learned how to do binary. And I learned how to do binary with just a very small little switch that only had 8 bits on it. But with those 8 bits, you could do a whole bunch of things. There was a lot of little projects that came with that little Radio Shack kit I got, that you could do LAD combinations, you could do Boolean logic. So I learned how to do Boolean logic at a young age, and it kind of stuck with me for a long time, even though I didn't quite understand it. I mean, I was 3 or 4 at the time. I didn't know how to do anything, but I had an interest for electronics, and so my dad kind of got that stuff for me, because before then I had torn apart my toy fire truck, took it completely apart, put it completely back together with no tools, by the way, which is a miracle when you really think about it, because toys back then had metal parts, screws, latches, everything. You couldn't get them apart. But I took it apart, messed with the wires, put it back together, somehow managed to make it work again. But he gave me the kit, and I learned how to do Boolean and binary logic with it, because you could take something and you could build a simple circuit that would take this dip switch, and you could tie it to 3 or 4 lights, you could tie it to a speaker, and depending on the combination of bytes you put in it, and then when you turned it on, it would do something differently. And this is fundamentally what programming is. Programming is fundamentally building up a logic situation with bytes to do a different task. And at the fundamental level of programming, that's all it really is, except that there's certain combinations of bytes that do certain things. When it actually comes down, I can't remember the entire system, but we'll go ahead and we'll pull up Notepad just to kind of talk about this. So at the basic level of your CPU has a built-in language inside of it, and not a lot of people really understand this and really know about this. This is the reason why you cannot make software for one CPU and it just works on another without those CPUs supporting the same logic. So you'll have a CPU that have logic, and it'll have simple logic. It'll have add, subtract, it'll have a method for doing retrieval of data, so you'll have like get data, store data, and this is not exactly what it is, but what these will actually end up being is you'll have something like this. These will actually be, and you'll do something like that, and it'll be a byte or more long. It depends on the CPU. Earlier CPUs it's going to be smaller, later CPUs it's going to be bigger. Specifically modern CPUs, it's 64 bits long. His reason why it's a 64-bit operating system is you can have a 64-bit string of stuff you can shove into the processor. But you'll see these little combinations, and what will happen is you will have this, and this will actually probably be a byte by itself, so you'll have a byte dedicated to this, and then you'll have another byte which will tell it the memory location. So I want to add whatever is currently in my buffer to whatever is in the memory location 1, and it will retrieve and do everything else. It's actually a really cool piece of software that I have on my computer. This is where I learned this. This is one of the things I actually ended up learning later on. It's a more modern thing I learned, but it's not something I started with. I didn't actually start with learning some of this stuff, but it comes into play to this conversation. So somewhere in my Google Drive, if I can find it, or not my Google Drive, but my GitHub folder, I have a class file for when I took stuff. These are like a lot of the classes I've actually taken over time. Not all of them, because not all of them are stored in here, but a lot of the ones that have code with them. It was an intro to computer programming. See if I can remember what it was. It's going to be probably the ones that doesn't have a number. It's probably this one. Yeah, here it is, Little Man Computer. So there's this little piece of software. It's really, really cool, and anybody who wants to learn how to program at a more fundamental level should get this machine. This will teach you how a computer works on every single regard, for the simple fact that you only have a single input, a single calculator, and only 100 lines of memory to work with. And you can load programs in here. So let me see if I can actually remember how to load a piece of software in here. Let's see, file, open. I have a couple pieces of software in here. And actually, they give you examples. I don't know, I guess examples don't work. Maybe I need to open assembly editor. Aha, here's how you do it. And then you can hit open with this and you can go to examples. And they got really simple examples. So like say for example you want to do division. So here's a program how to do the division. And it pulls in 2 data points. So it'll store A and it'll store B. It will then do a series of tasks on it, and then it will output all your information. It's got, of course, some other stuff here, like you can make some labels. You can, so that way it's a little easier. So instead of calling line 19 up here at A, you just call whatever's stored at this spot, which is going to be this information. And we can actually compile this. So I don't want to care about compile log. It'll load the memory in here, so you can see how it loads all the memory, and this will run it. So if I input, I want to divide 10 by 2, and then I can hit run. And you can watch it. You can actually sit here and watch the program run. Now this is animated, of course, to give you a better concept of what the machine does. But it'll go through and it'll read the program. So it reads the program one line at a time and does everything else, and etc., etc. This is something that is fundamental of how it works. And this is basically the same concept behind dip switches and doing Boolean logic. The only difference is this was a single run of operation. So every time I cycle the machine on and I cycle the machine off, I was running a single run of operation. So a single loop of this. My memory was the dip switches. My program operations of running was the signals coming in. So I would have different power signals coming in off of a rail. We would have it in a little board kind of like this, which would have electricity coming into different pins and going out, and it would do the logic. So that would be the similar concept, and that's the reason I bring that up. But that was my first experience with what can be perceived as programming. Now at the time that definitely, and still probably even today, would not be considered programming, but I considered it because at fundamental level, that's what it is. My next exposure to programming was at some point, like somewhere between the ages of like, I don't want to say 8 to 12, I got some programming books from the library. I liked video games. I had been toying with video games for a while, and I wanted to make my own video game. And I'm like, hey, this can't be that hard. Let's go get a book from the library and let's learn how to program. So I got some books from the library. I got some various other things. At the same time, I was also learning how to do electronics properly. I actually got a lot more books on electronics and schematic design and circuitry and engineering than I did programming, because at the time, that's what I really wanted to do, was electronics. Programming was something I got into because it was cool. That's really the reason I even started in it. It was kind of cool. So I toyed around with it, and I built some very simple programs. I built, so my very first programs I built were command line programs for mini games. I had a command line pirate ship game I built. It took me like 2 months to make it. It was like one of the proudest things I ever built, but I made it, and it was kind of cool. I did it, and I didn't really do anything with it after that. I kind of was interested, but because of how young I was, I really wasn't making it very far on my own, and I couldn't find the resources necessary to really learn how to program on my own. I actually spent a lot of time asking for help and trying to find somebody to mentor me, which never happened. And of course, my parents didn't think programming was something I should have been learning, because of course, programmers weren't a common job at the time. I mean, they existed. There definitely were programmers or people who made operating systems, but that was something people did over in California, not where I live in Ohio. Still to this day, there is programming jobs in Ohio, but not like very advanced programming jobs. But that was something I exposed to. I didn't really toy with it much again. I did try a few more times. I tried learning XNA, which was C#. That was Microsoft's programming system for making games for the Xbox 360. I toyed with that for a while, made a few small games, even managed to load one up on the Xbox and play it. That was amazingly cool. So I built an asteroid game, and I built a few other things. I was constantly designing stuff too as well throughout that entire time, but I never really properly learned how to program. I did in junior high finally take a Visual Basic course and an HTML course, and finally did that kind of stuff. I also did another web design course, I believe, prior to that. And so I learned basic web design. I learned how to make websites. I learned how to make form applications in Visual Basic. I also kind of made another game in Visual Basic. Of course, you can see a pattern here. I really did like the idea of making games. I made a small little turn-based strategy game. Once again, it was command line driven, but what you could do is have 2 players play, and you could make units and store them up on tiles. And you couldn't see the tiles, of course, because this was kind of more command line, but it was built into like a visual form-based application. So for this, you know what a form-based application is. Form application software. So let's see if we can find a decent picture. So it looked like something like this, and you had this, and you could put in, you can ask like what units you wanted to make and everything else. And I made it work. It could play. I didn't keep the code for it because it was stored on a public computer for the school. So eventually I lost the code, but it was kind of cool. So I messed with that. Didn't mess with it ever again. I didn't touch programming probably again until I got to my last 2 years of high school when I started studying electronics. In electronics, we learned programming because when you make electrical systems, you need to embed software on them. So if you want something more complicated than just being able to turn a switch off and on, say you want to have a timer, or you want to have a counter, or you want to control LED lights or something, you're going to need something more complicated. So I learned how to program little basic PIC controllers. And let me find a PIC this. PIC... just electronics to see if I can find it. So basically these little guys. It's not the exact one. I have a box of them around here. I actually bought a ton of these because they're like, you can buy them for 50 cents and you can program them with a little piece of hardware that only costs $10. So a lot of people, what they'll do when they actually do this stuff is they'll go and buy an Arduino, if I can remember how to spell Arduino. I've never actually owned one. I actually really would like to. Arduino, there we go. So a lot of people will buy Arduinos, and these are basically more complicated, and you'll see these range from all kinds of different prices. The one people usually end up buying are the larger kits, and they've actually dropped significantly in price over the years. They used to be, back when I started doing electronics in high school, they used to cost like $100 for a kit like this. Now you can get these kits for $30, but that board right there in the corner here, that's basically it. You see the little chip on it? I could go and buy that for 50 cents, and I could buy a board for like $10 to program it. I could program the chip, put it into that little green board there, and just do whatever I wanted to with it, and it would work. So that's kind of another time I really got to mess with programming. Sometime also in my last 2 years of high school, back in 2010, I started making Minecraft mods. I had been exposed to the game. My buddy Shadow had showed me the game. I still hang out with him, actually. But he showed me the game, and I fell in love with Minecraft. Got a lot of stuff to do with it. I used to build giant mines, used to build mine tunnels. I started with the creative version because I couldn't afford the real version when it came out, but I played the creative version a lot, and did that. Our whole class played the creative version. It was a really cool thing. When I was in high school, our professor didn't really care what we did, so as long as we did the work during the day, whatever time we had left over in the day, he said, okay, you guys can play games. So we played Halo Custom Edition, we played Minecraft, we played Command & Conquer, and we did that all day long. Learned a lot of team building in that process, by the way. That was our excuse, by the way, when the principal asked, why are you guys playing games? We're learning team building. We're learning how to interact with each other in a teamly, conductive way. That was a getaway, especially the Minecraft stuff. When you got redstone finally in there, that was amazing, because we could actually use redstone to do Boolean logic, discrete mathematics, stuff like that. But so 2010, I did make my first mod. My first mod was a Dirt to Diamonds mod. I built that with a lot of help. Back then there wasn't really tutorials, there was nobody you can ask for help, the forums didn't really exist, so you had to kind of do things on your own, and there was no mod loader, there was no Forge, there was no FML. MCP kind of existed at the time, but I don't think it was even called MCP. For those who don't know what MCP is, that's Minecraft Coder Pack. It's what we used to decompile Minecraft to work on it. So there was something like it, I don't know if it was about the same name, but you had to use that to decompile Minecraft. Then you had to make changes to the Minecraft code, then recompile it, then pull your changes out, then insert those in the Minecraft jar, then run Minecraft. That's how you actually modded back then. I made a Dirt to Diamond mod that way. I actually made a few different things, but that was the only one I actually remembered. So I toyed around with that one. I didn't actually keep with it because I really honestly did not understand how to program back then. I'm almost entirely so where I say anything before 2011 doesn't matter, because I wasn't a programmer and I didn't care to be one. I was simply doing stuff because I wanted to do it. And that's one of the biggest things, like, which a big thing when you guys are learning to program, don't really focus on programming as the thing, focus on it as a tool. The real goal is to do something. Your goal is to have a purpose for the reason to program it. It could be almost anything. It doesn't have to be complicated, doesn't have to be small, doesn't have to be, it could be whatever you want. You'll see very often that I program currently, I make small stuff now. And the reason I do it is because it's much more enjoyable and everything else, so that's not important. Going back to the story of my programming experience. So I didn't touch programming again until I think it was my second quarter of college. So I graduated high school 2011. I worked as an electronics technician for several months and then went and quit, and I actually really sad about quitting that job. It was amazing. And then I went to college as an engineer. So I did that for a while. And I took a couple programming classes. My original reason for taking a programming class, one was, the face reason was I was like, hey, I'll learn to program. and that'll support my ability as an engineer to work better, because embedded systems were a thing. So embedded system is basically what we're talking about with Arduino, is that you're embedding code onto a piece of hardware to run, and that piece of code will always be there. It'll always be running, always be doing stuff, always be kind of whatever, but it'll be embedded on the hardware. So I was like, hey, I'll learn to program, and then when I become an engineer, I'll do electronics, I'll understand how an embedded system works and stuff. That was what I kind of said. The reality of it, and I kind of learned this later on, I actually did want to be a programmer, and I always had wanted to be a programmer. I always wanted to do games and everything else, and it becomes really obvious. So I actually go through and explain my entire life. I'd always, as a kid, all the way up to graduating high school, had been designing games, software, robotics. I have notebooks upon notebooks upon notebooks of stuff, but that's not the point of the story. So I took a couple programming classes. I got kind of interested in it. Didn't do a lot with it. Did the classes, was kind of cool. Was too busy working on my physics classes and chemistry and stuff like that, thermodynamics, to really care too much. But it was when I hit my second semester of physics class that the mathematics started becoming so complicated that trying to do them on paper was becoming almost impossible to do. So I started looking for software to do this. I couldn't find easy to use software. A lot of it was still required you to know how to do things. So I fell back on programming. At the time I had learned Java. I learned that because one, I was toying with mods back in the day, and I had just taken a class on C++ and Java. So I had learned how to do those two languages. So C++ was a little too hard to work with, because at the time the compilers were finicky. So you would get an editor, you would write all your code, and then you would still have to go through a very lengthy process to compile your code. Java, you installed Eclipse, wrote your code, hit compile, you were done. You could even hit export jar and you would be able to do that. So much easier, so I picked it for that reason. It was also easier to understand because you didn't have to manage your own memory and everything else. So I went with that option and started using Java, started making pieces of software to help me with my mathematics, started making software to do physics simulation. This is where it kind of really dawned on me of just how amazing programming was. I took what normally would take me 50 plus pages to do physics simulation wise, wrote that down into a series of 100 lines of code, and would have it output all the mathematics I would normally do. All the work showed how to do it, which I could just print off and submit as part of my homework, and then have it like do visualizations of the data, so I could actually show graphs of the data changing. I could do say for example, we did a lot of physics stuff. I mean, we did a little bit of everything. We did car crashes, we did black holes, we did asteroids, we did things like marbles bouncing off of things. Like my favorite one, which was on a exam that I failed because I was actually not that good at physics. I never was. It really just came down to that I had become so sleep deprived in my final couple of semesters of college at the university I was going to that I just failed to brain half the time. But the one I remember I was really fond of was a French fry in a deep fryer. You had to calculate the French fry being bounced off of a counter, flying through the air, bouncing off a few different objects, landing in the fryer, frying, then bouncing, in which it would gain, it would change the material of it. So you had to do like aerodynamics and stuff. So you had to calculate the air resistance. And when it went out into the deep fryer and then came back out of the deep fryer, not only did it gain weight, the French fry gained weight, its shape changed, and then its air resistance changed, and then its friction on hitting objects changed as well. It was an amazing like calculation I had to do. I actually got the first half right, and then at some point I messed up some conversions and got the rest wrong. But the professor still gave me a decent passing grade. I got a C on it. And I got a C because that professor just liked me when it came to that class. But that's like a really good example. So I got into programming doing that kind of stuff. And I started making mods again at that point. So this is kind of where I say everything after 2011 is when it really starts to matter, because that's when I started truly learning programming. I truly started paying attention to what I was doing, and I started actually making proper mods. This is, of course, when ModLoader existed. We didn't have a multiplayer system, so you still had to make like single player stuff. I think eventually we got a multiplayer ModLoader at some point. Was not the most easiest thing in the world. But some of the very first mods I ever actually made was a Sentry Gun mod and the Guardsman mod. The Guardsman mod was a little protection mod to actually protect entities and just kind of do his thing. It was basically I made some skeletons that didn't look like skeletons that would shoot everything else but the player. It worked, it was fun. Eventually that actually evolved into a really nice mod, and it was the basis of what ended up becoming the Arclix mod at some point. But moving on. So we got into that. I started properly learning how to mod, properly learning how to code. I still didn't know anything. So for those of you guys who come into modding right now, you would be on the same level I was back when I actually started modding as well. I didn't know anything. Even with all my years of experience of dealing with coding and programming, it didn't mean anything because I didn't pay attention. This is a really big point when people ask, how do I know how to program? I know how to program from the very simple thing of this. Well, I can actually phrase this in a much simpler way than I was about to. My electronics professor in high school had this very simple saying: pay attention to the details. Like, that's as simple as it gets. If you do not pay attention to details and you learn something, and if you don't actually pay attention to what you're learning, you're not going to learn it. You're going to learn how to, say, for example, swing a hammer, but you're not going to learn why it is you're swinging that hammer as fast as you are, why you're hitting from this angle, not that angle, why you have to hold it in your right hand versus your left hand, why you can't hold it backwards, why you can't swing from a different direction. And this is a really good example that he gave, and it makes a lot of sense. If you simply learn to do a task, you will not actually learn to do the task. You will learn to replicate the task. You will learn to mimic, mirror, and fake doing the task, but you have not learned how to do the task. There's even a funnier story that I ended up actually reading. I've heard the story a few times of this ship that had broken down. And the owners of the ship kept hiring experts to come in and repair the ship. Nobody could figure out how to repair it. Then they hired a guy that was not an expert, but had been working on ships for his entire life. He comes in, and they're watching him work on the ship, and he looks around for a while. He looks around the engine, kind of does some things, pulls out a small hammer of his tool bag, hits the engine starts working again, and then he walks away and then sends them the bill. And they're kind of baffled. He sends them a bill for like $30,000, and they're like, wait, why are you charging us $30,000? You only hit it with a hammer. Send us the itemized bill. And he sends them an itemized bill, $2 for swinging the hammer, 29,000 something and so for knowing where to hit on the hammer. And this is an example of paying attention to the details. He knows what he's doing because of his amount of experience in paying attention. He's never been trained to fix a ship. He's never done it. He's never been considered an expert. The experts couldn't do it, but he could. And it's a great example of paying attention. That's one of the reasons why I actually know as much as I do, is I pay attention. I take time to learn certain things. I go through and read code. So when I have code like this, and this very often you'll find this, and a lot of people who start modding, they fail to do this as well. And this is one of the things where I kind of get mad at a lot of tutorials that exist for Minecraft. A lot of tutorials will just simply tell you, okay, this is how you make an item, here's how you make a mod class, here's how you do this, you put this stuff on here, you do this, and so on, and you're done, you got an item. But that doesn't tell you how to mod. That tells you how to mirror a template to make something. In order to properly mod, you have to actually start to understand how to look for the information you want to find. And this is true for any type of task you will ever do in your entire life. You need to learn how to find the information. You need to learn who to ask for help. You need to learn where the information is, what sources are good, what sources are not good, trustworthiness, everything else. There's a whole entire, like, I took an entire class in college on just critiquing information, like understanding what is good information, what is bad information. I wish this was something that was taught in high school to people, because you'll find people that do this all the time where they'll go like, that's a trustworthy piece of information, and then you'll come in and you'll look at it like, that not only is that not trustworthy, there's not a single piece of truth in that entire system. That's not important. I can go on a topic of that entire thing by itself, and I'm probably going to avoid doing that because I don't like talking about politics on my channel. But learning how to find the code is really important. So we get the world class, and most people don't know how to actually get to these and stuff. So say you're working on your system and you just don't remember method names or anything else. What you can do is, you can find the object that you want to look at. So say, for example, I want to figure out what methods are inside GUI image button. I can hit Control B and IntelliJ, and there's a hotkey in Eclipse as well for this. There's a hotkey in almost every IDE for this. And if you can't figure out how to get the hotkey, you can usually find the file. So say, for example, I didn't know how to use the hotkey, you can go to Project Structure in here. Actually, no, Project Structure is not the proper way to do this. It's one way you could do this. But you can look at project files. And actually, let's do... Here we go. This is a good way to do it. So at the bottom of here will be all the dependencies. And what you can do is you can come down here and you can find, say, Industrialcraft. You want to look at Industrialcraft, you can go look at its code. You can go look at Java's code. I have all these dependencies in here. Open computers, not enough items. Forge is the one you usually want to look for if you ever get in here. So Forge source, you can go in here. Here's not only is the Forge source, but the Minecraft source in here. You can then navigate through this. You can go, okay, like, what is Minecraft in it? Like, what are the blocks? I can go look at every single block in here. I can click the block and I can read its code. And if you're in 1.7, you'll get really nasty code. You're 1.12, it looks a lot nicer, by the way. Just if you go to make a mod for the latest version. Don't make a mod for an older version, unless you have a goal in mind for that. But we'll get into a subject on that another time. But knowing where to find this stuff is very important. So say, for example, I wanted to support crops, and I wanted to know how a crop worked. I can come into this class file. I can start reading over here. It goes, okay, the crop is only placeable in farmland. Can place, has to be farmland. Every update tick, it does some very basic growth checks. It checks to see if there's lighting. So you understand lighting, and you see some magic numbers here. So where you have to do some experimentation and actually do some research. But what it does is it goes, okay, what is the light level directly above me? And is that light level greater than 9? By the way, light level goes between 0 and 15. It's something you will have to like learn how to do, and to find how that information works. You actually can go like this, and you can sometimes occasionally find Java docs. and you might actually find some other things. Like there's some Java docs that actually will tell you what's going on. By the way, if you actually write your own code, make sure you document everything, because not only will it help you, or actually let me phrase it, not only will it help somebody else who wants to help you fix your code will need those Java docs, and it will help yourself when you're 10 months down the road and you've completely forgotten what you're doing. Very useful to have Java docs. So let's get back into that crop. So you get a crop, you can read this, you can go through and you can figure stuff out. Now, of course, you're going to have some understanding of everything else, but you can continue hitting the Control B and IntelliJ and keep following the code. Just sit there and follow the code. This is how I actually know how to work in Minecraft. I was never taught by somebody how to make Minecraft mods. I had to entirely reverse engineer things, and it's the reason why I'm incredibly good at it too. I spent years just sitting here reading code, and if you want to learn, this is a really good way to do it. Go find somebody's project. If you want to say, for example, if you wanted to make an industrial craft mod, and I don't actually recommend copying industrial craft because its code is not the greatest, but you can go read industrial craft code. You can go through there and go, okay, how does player program all this stuff? And I don't think his player even works on it anymore. You can go look at thermal expansion. How does King Lemming make all this stuff? How does Skyboy program all this stuff? You can go through all the code and you read it, and you can read through all of it. And you want to also read multiple sources. You usually always want to look at Minecraft first, look at how Minecraft does it, then look at how a mod does it, then compare and contrast and figure out what are the differences. And just read through it. Just slowly read through it. If you don't understand something, print it out, write notes next to it. Go like, okay, what is this variable? We don't know what these variables are. Of course, these are X, Y, and Z, which you'll figure out at some point. But if you didn't know what they were, okay, write notes. Just start reading through. Like, okay, we're checking, why are we checking greater than this? You start writing notes like, why is it doing this? Always ask the question why, and repeatedly sit there and ask it over and over again until you get an answer. If you can't come up with the answer quickly, maybe set it aside for a while, go work on something else for a while, because it'll eventually dawn on you. Something you're working on will eventually bring information to you. And you can sit here and read through this code over and over again. So that's the reason I know how to work on Minecraft. Now, the reason I know how to program, as I said, I pay attention to details. I go out there and I read different source articles. I've also been formally trained at this point because I'm going to have a bachelor's of computer science here in like 2 months. So I have been formally trained, and that does help massively. So taking classes online is a really good way to learn a program. Watching YouTube. I consume so much YouTube per day that it would blow your guys' mind. And a lot of stuff I do watch. I watch a lot of educational stuff. I watch a lot of everything. I don't just focus on programming too. This is a really big thing that a lot of people I've watched say to people like, hey, if you're going to want to learn a part of program, go learn how to program. And that's not exactly how you learn how to program. It does work. You can go out there and just go, okay, look for programming help guides. But when you want to learn to do any profession, you want to learn the profession and everything else around it. So, and by everything, I mean everything. Learning how to farm will help you learn how to program. And it's the funniest thing you ever hear, and for this, you've never heard this story. So the television, when it was invented, the guy who made the fundamental concept of it, who invented the technology, was a farm boy in high school. He figured out the concept of projecting pixels, or they weren't even pixels, they were like light beams or whatever, onto a screen by looking at a field of corn. And that's how he actually figured it out. He sat there and looked at a field of corn and went, you know what? We farm the field of corn from left to right, up or down, and we go back and forth, and we just do that. So, and he saw that, you know what? Wait, what if we project a light beam at a screen and just go from left to right, back and forth, and just project the image we want to project? And he built a concept off that, and he knew nothing about what he was doing, but he did that, and it's simply because he understood the concept of farming. And this relates back to programming as well. Everything touches programming, almost completely everything. And to even emphasize even more, the most important classes I've ever taken in college have nothing to do with programming. The ones I actually treasure the most are my communication classes. I took classes, they were English-based classes, so they were actually writing classes, but they taught you how to communicate. They taught you how to read. They taught you how to write. They taught you how to talk to another person, how to understand and empathize with another person. And I get frustrated sometimes at other developers for this. When a user comes to you and he's angry, he's not angry at you. He's angry because he's been sitting there dealing with some issue. And rather than getting aggressive or angry back to them, just empathize with them. Go, yeah, I know you're in a shitty situation. Let's work through it. Let me help you, or you help me help you, and so on and so on. And that's like those communication classes have taught me that. Plus, my experience working for Verizon as customer service also made a huge difference in that regard too. The next course after that I really, really cherish, and I was talking to somebody else about this the other day when I was giving out a new mod design. I actually have another mod I've got in progress. I'll be posting it up on Patreon when I get the designs done. But I took a class on system theory. This is an entire class dedicated to understanding how systems work together, how they break down, how they simplify, the different difficulties. That class taught me such a massive amount of insight into how systems work that I completely picture my code differently after that. And instead of staring at my code and going, hey, this is a function, or this is a method that does something, I go, this is a building block that fits into a system, and that system does something. And this is a system on its own. This is a system that just is checks for light level. And you start picturing it not in terms of the code, but in the terms of the results of the code. And this is a really big thing, by the way. This is something I try to emphasize a lot to people. When you're making projects, don't worry about how shitty your code is. Don't worry about the presentation. The only thing that is ever important when you do something is the result. What is it that you accomplished? What is it that you did? Did you learn something? If you learned something, the result's good. If you made something cool, the result's good. If you accomplished something that you always wanted to do, the result is good. Don't care about somebody coming in going like, oh, your code's shit, you're doing it the wrong way. That doesn't matter. Like, you can learn, like, pay attention to what they say, but don't give emphasis on the way they say it. Look at, like, say, like, if they say, oh, hey, you did it the wrong way, I go, oh, cool, I did it the wrong way, tell me what the right way is. And then listen to what the right way is, and then completely ignore the guy being mad, especially if you run into shadows in the mod development Discord. That guy can get pretty mad at you for everything else. That's not to be confused with the shadow that sits in my Discord, by the way. They're two different people. But he'll get mad at you, and I've seen other developers get mad at people for programming wrong. Ignore those guys, listen to what they say, but don't put emphasis on it. And anybody else tells you your code shit, listen to what they say, but don't emphasize on what they're saying. So don't listen to the negativity, is basically what I'm trying to say. That's another reason how I got as good as I am. If I listened to the negativity a lot, I would have quit a long time ago, because when I worked for CalClavia, people think when I worked for the UE team, it was all like happy thoughts and pixies and fairies. It was not. The UE team was probably the worst disaster I've ever been on for a team. We barely coordinated. CalClavia chewed out every developer on the team. We had a dystopian failure of a large proportion, but it worked. We got good results. And eventually we learned to coordinate, and eventually we subjugated CalClavia and taught him to stop being mad at people. But if I let people tell me I was doing the wrong thing constantly negate me, I would have stopped learning how to program properly. I actually used it as a motivation. If somebody tells me I'm doing the wrong way, then I'm going to improve. I force myself to improve. That's another reason I got as good as I got right now. Moving on, which I completely lost in my train of thought here. There's a lot to like learning a lot of this stuff, and there's a lot of detail, and I could probably make videos for days just telling you how to do things. But the biggest thing to learning how to program, you just got to start doing it. And there is a meme for this, where I forget the name of the guy that just goes, just do it type of thing. He is right. That's actually how programming kind of works. You just got to start doing it. You just got to slowly work your way through. Start with the fundamentals. This is a big thing that you'll see mod developers tell newbies, is you got to learn the basics of Java. It is important. You want to learn the basics of Java. You don't have to necessarily know Java to start modding, but if you want to be a successful modder, it really does help. It helps such a massive amount. I used to be against the concept when I started modding. I was like, I didn't need to learn how to do the basics of Java. I just want to learn how to mod, and I just wanted to do stuff. After I learned the basics of Java, the amount of productivity I went through was massive. I went from struggling to understand how code worked to actually being able to make my own code. So learning the basics of Java is helpful. More importantly, you want to learn the names of things just so you can communicate with your fellow developers. This is a method. This is a parameter. These are if statements, Boolean checks. These are, I want to say variables. I sometimes occasionally call them fields. Fields are actually this stuff up here. It's a class, constructor, so on and so on. You want to learn the basic data. You want to learn to document your code. That's a very big thing. Emphasize on that constantly. Write notes throughout your entire code. Make it as readable as possible. Biggest thing you can ever focus on when learning how to program. Learn to make your code readable. Use proper names for everything. Don't try to use simple variables. It's going to screw you up. It's going to screw up whoever's going to help you. If you have to think about what you're doing when you're reading your code, that means somebody else has to think about what they're doing when they're reading your code. So if you can make your readability improve, it's all the better. Leave notes everywhere. You won't see this in Minecraft code, but if you come over like to some of my code, and you'll start seeing stuff like this. Like this is the add scroll button. You'll see things like this. That's not the greatest example. It's my GUI code because I wrote this one day when I was half asleep, and I have yet to go through and document it properly. But you want to put documentation up here. And for example, you want to simply say this is like the user interface for the Sentry handles 5 different tabs. You want to put some basic documentation on your code, and it really does help. Don't worry too much about spelling. Try to get it right, but I mean, it's not that big of a deal. Other things on emphasizing on this, like spend time just learning different things. Watch videos on how to do stuff, especially core concepts. Programming is cool, but if you don't learn the core concepts, it's really difficult. And don't just learn one programming language. Take some time to look at other programming language, because something that may exist in another programming language will exist in the language you're trying to learn. Although do pick one to primarily start with, and don't overextend yourself. Take time. Do a couple hours of programming a day, but don't burn yourself out. Burnout is a really big problem programmers have, and I'm a really good example of somebody who has taken the point of burnout to the point that I have caused myself serious harm before. I went 12 days without sleep one time, and more or less got told by my doctor that I had a heart attack at the end of that 12 days. So don't do that. Take it easy, take it slow. You want to start a couple hours a day learning how to program. Look at all kinds of sources, read articles, watch videos. Books are not as important. Books can teach you a lot, but it's the right type of books. There are a few I will post up on Twitter, if I recall right, of books that actually are really good that should be learned. Like there's a book on system theory that is amazing. There's a book on team leadership that I have that is absolutely amazing. But then I have books over here, like I got one sitting on my desk that's on servlets and JSPs, which is programming with Java for web applications. It's kind of useful. It does teach you how to do stuff, and it's a great follow along example, but for the cost I paid for it, I could have went online, found some site on Google, and saved myself a ton of money. Try Google first, always. If you always have a problem, Google's a great place to look. Stack Overflow is amazing. Look over there. Almost always somebody's had a problem and they've put it on Stack Overflow. You just got to change your wording. Learning how to Google is like a really good important thing on that, and at this point I've run out of steam, so I'll cover some more of this here later and ramble on another time. But this has been what was supposed to be a short talk, turned into a 36-minute ramble. But I'll see you guys later, and hopefully this has helped somebody.